Hi student, this is Sivakumar. 11th standard mathematics chapter number 6 continuation of exercise 6.4. Now problem number 5. Prove that the equation to the straight lines through the origin, each of which makes an angle alpha with the straight line y that is equal to x is x squared minus 2xy into secant 2 alpha plus y squared that is equal to 0. Here is question number 5. First we can construct a line y that is equal to x. Look at that, y that is equal to x, y. For constructing a straight line I take minus 2, minus 1, 0, 1 and 2. Just I have taken that 5 values of x. If you replace x by minus 2, we'll be getting y also minus 2 because y and the x are equal. Y that is equal to minus 2, like that here minus 1. If you replace 0, y also 0, like that 1 here, 2 here. So I'm going to plot all the 5 points in a straight line. For constructing straight line, only 2 points enough. But I have taken here 5 points. Your x-axis, y-axis, okay, this is x dash, y dash. Here I take that 1, 2, 0, minus 1, minus 2, here 1, 2, minus 1, minus 2, enough. Here first point is minus 2 comma minus 2. You know that how to plot a point in a graph. Minus 2 lies in third quadrant, and the next one is minus 1 comma minus 1, that is also lying in third quadrant, and 0 comma 0, it's the intersection of both the axes. And the next point is 1 comma 1, and the last one is 2 comma 2. 1 comma 1 in first quadrant and 2 comma 2 also in first quadrant. So all the 5 points lie on a same straight line. I'm going to join all the 5 points now, and even I can extend. Okay, so look at the straight line. The straight line is passing through the origin, and it is passing through that first quadrant as well as in third quadrant. It is passing through first quadrant as well as in third quadrant. This is y that is equal to x. Okay, here what is given? Equation of straight lines through the origin, each of which makes an angle alpha with the straight line y equal to x. So that I'm going to draw a line passing through the origin. One line and one more line. It is also passing through the origin. Okay. So according to this problem, each and every one is making an angle alpha with the line y equal to x, that is given. So angle between these two is alpha, for these two also alpha. So angle between this green color line and the line y equal to x is alpha, and another green color line that is also passing through the origin with the line y equal to x also alpha, according to the problem. Okay, then for this line y equal to x, that line makes an angle 45 degree with the x-axis. How it comes? Listen now. Given line is given y that is equal to x. What form it is? Y that is equal to mx, and m is a coefficient of x. Here the coefficient of x is 1. Therefore, m that is equal to 1. M represents slope. That slope can be replaced by the formula tan theta. Tan theta that is equal to 1, which implies tan theta that is equal to this. 1 can be replaced by tan 45 degree, because tan 45 degree is 1. Now you can compare these two. Theta that is equal to 45 degree. So what about the angle? Theta that is equal to 45 degree. From here to here, the y equal to x makes an angle 45 degree with x-axis. Now let it be line number 1 and line number 2. For line number 1, what is the angle? This is a 45 degree. This one is alpha. So what about this angle? This line L1 makes an angle 45 minus alpha. Correct? Please add these two, you will be getting 45 degree, because this is 45 degree. No, if you add, you will be getting that 45 degree, because if you add plus alpha minus alpha get cancelled, you will be getting 45 degree. From here to here, the angle is 45 degree. Next, angle between line 2 and x-axis, that is from here to here. That is, we know this is 45 degree, this one is alpha, so together 45 degree plus alpha. Come on, once again, 45 plus alpha, so full angle that is 45 degree plus alpha. Since L1 and L2 both pass through the origin, I consider L1 that is equal to equation of L1 as y that is equal to m1x. Y that is equal to m1x. Whenever the line is passing through the origin, you can write y that is equal to mx. Here I consider, let L1 that is y1 equal to m1x. Sorry, y that is equal to m1x. And L2 that is y that is equal to m2x. Okay. Now I'm going to write m1 and m2. Here m1 that is equal to tan of, what is the angle? Here it is. For m1 the angle is 45 degree minus alpha. 45 degree minus alpha. Minus alpha. It can be simplified, that is equal to tan 45 minus tan alpha divided by 1 plus tan 45 into tan alpha, because this is of the form tan of a minus b. Since we can write the formula over here, since the tan of a minus b that is equal to tan of a minus b or tan of x minus y, you can write a tan a minus tan b divided by 1 plus tan a into tan b. Have applied this formula here. I am going to simplify. So that is equal to tan 45 is 1 minus tan alpha divided by 1 plus tan 45 is 1 into tan alpha. That is equal to 1 minus tan alpha divided by 1 plus 1 into tan alpha, tan alpha. Let it be. Now m2 that is equal to, m2 is a slope of the second line. Okay, m2 that is equal to, and m2 that is equal to tan of, look at the angle here, m2 angle here, it is, m2 is the slope of the line L2, 45 degree plus alpha, 45 degree plus alpha. Here this is of the form tan of a plus b. Since tan of a plus b, that is equal to tan a plus tan b divided by 1 minus tan a into tan b, that is equal to, now you can apply the formula, tan 45 degree plus tan alpha divided by 1 minus tan 45 degree into tan alpha, that is equal to tan 45 degree value is 1 plus tan alpha divided by 1 minus tan 45 degrees 1 into tan alpha, that is equal to 1 plus tan alpha divided by 1 minus 1 into tan alpha, that is tan alpha. Now we got the values of m1 and m2. I am going to replace in L1 and L2. Let it be number 1 and number 2. Therefore 1 implies, what is equation number 1? Y that is equal to m1x, y that is equal to m1x, m1 that is and equation 2 implies, I have written once again, y that is equal to m2x. Okay, listen, which implies y minus m1x that is equal to 0. I have taken that m1x to the left hand side. Here y minus m2x that is equal to 0. Now we have the two separate equations. Now combine the equation of two straight lines. Therefore combined equation of two straight lines, that is, you have to multiply these two. So y minus m1x into y minus m2x, that is equal to, multiply both the right hand side, 0 into 0, that is equal to 0. Now normal multiplication, y into y, that is y square, y into m2x, that is minus m2 into yx or xy, minus m1 into xy, m1 into xy, minus into minus plus m1 into m2, m1 into m2, x into x square, that is equal to 0. Which implies, first write that m1 into m2 x square. First write that x square term, m1 into m2 into x square. Then between these two you can take minus xy as common, minus xy as common. If you take xy as common, here m2 will be there, here m1 will be there, you write m1 plus m2, because already I have taken minus common, so plus will be there. Finally write y square, that is equal to 0. Let it be number 3. Okay, now I am going to find out m1, m2 and m1 plus m2. Already we have m1 and m2. First we can find m1 into m2. Consider m1 into m2. Consider m1 into m2, m1 value into m2 value. m1 value, here it is 1 minus, look at that, this is m1, this is m2. m1 that is 1 minus tan alpha divided by 1 plus tan alpha, 1 minus tan alpha divided by 1 plus tan alpha, and m2 value, here it is, that is 1 plus tan alpha divided by 1 minus tan alpha, 1 plus tan alpha divided by 1 minus tan alpha. Now we can simplify, these two get cancelled because it's a product, and these two get cancelled, that is equal to 1. All get cancelled, will be getting 1. This is m1 into m2 value. Now consider m1 plus m2. You have to find out m1 plus m2 also. m1 value, that is, here it is 1 minus tan alpha divided by 1 plus tan alpha, plus m2 value 1 plus tan alpha divided by 1 minus tan alpha. Now I have to take the LCM. the LCM, you know that these two are nothing common between these two, so the LCM is multiply these two, 1 plus tan alpha into 1 minus tan alpha. Since nothing common, just you have to multiply these two, that is 1 minus tan alpha into 1 minus tan alpha, that is whole square. Like that. If you multiply, you'll be getting 1 plus tan alpha, the whole square, equals. Here you can apply a minus b whole square formula. If you apply, you'll be getting a square plus b square, that is tan square alpha, minus 2ab, 2 into 1 into tan alpha, 2 tan alpha. You can directly write plus. Here you have to apply a plus b whole square formula. A, that is 1 squared is 1, plus b squared, that is tan squared alpha, plus 2ab, 2 into 1 into tan alpha, that is 2 tan alpha, whole divided by 1 minus tan alpha into 1 plus tan alpha. This is of the form a plus b into a minus b. A plus b into a minus b, you know that a squared minus b squared, that is 1 squared minus tan squared alpha. That is equal to, here you can simplify, minus 2 tan alpha and plus 2 tan alpha get cancelled. Then we have 1 plus 1, 2 in the numerator, plus tan square alpha, that is equal to 2 tan square alpha, whole divided by 1 squared is 1 minus tan squared alpha. That is equal to, these two cannot be added, but we can take 2 as common. If we take 2 as common, you'll be getting 1 plus tan squared alpha divided by 1 minus tan squared alpha. Okay. We know that 1 minus tan squared a divided by 1 plus tan squared a, that is equal to cos 2a. I write here, we know that 1 minus tan squared a divided by 1 plus tan squared a, that is equal to cos 2a, taking reciprocals on both sides. If we take reciprocals, the reciprocal of that left hand side is 1 plus tan square alpha divided by 1 minus tan square alpha, that is equal to, the reciprocal is 1 by cos 2a, which implies, write the left hand side as it is, 1 plus tan square alpha divided by 1 minus tan square alpha, that is equal to 1 minus cos, you know that is secant 2a. I write the reason here, since 1 by cos theta, that is equal to secant theta. So look at that. We have 1 plus tan square alpha by 1 minus tan square alpha. Here it is. So this can be replaced by secant 2 alpha, secant 2a. Sorry, here not alpha, here a. So reciprocal, that is a only, here a, here a, here a. So please listen. So this is the formula, 1 plus tan square alpha divided by 1 minus tan square alpha, that is equal to secant 2a. Again I tell you, sorry, 1 plus tan square a divided by 1 minus tan square a, that is equal to secant 2a. Instead of a we have alpha, so this can be written as 2 into secant 2 alpha. Okay, I have written the reason also here. Therefore, equation 3 implies, let it be equation number 3. This is equation number 3. Therefore, equation number 3 implies, please listen, m1 into m2 x square, m1 into m2 x square. m1 into m2 value, here it is, what it is, 1 into x square, 1 into x square, minus xy into m1 plus m2, xy into m1 plus m2, m1 plus m2 value, here it is, what it is, 2 secant 2 alpha, 2 secant 2 alpha. Finally, plus y squared equals 0, plus y squared equals 0, which implies 1 into x squared, 2 into secant 2 alpha into xy, secant 2 alpha into xy plus y square equal to 0, hence proved. Look at that, x square minus 2 secant 2 alpha into xy plus y square, here it is. Because you are asked to prove that equation only, x square minus 2xy into secant 2 alpha plus y square equal to 0. So problem number 5 is completed. Then I'll be teaching problem number 6 in the next video. Thank you, children.